Answer the following question. Prove that 1 minus cos 2x minus sine x over sine 2x minus cos x is equal to tan x. It is always easier to work from the long part of the question to the short part. In this case, what I mean is it's easier to break down the left-hand side so that it matches closer and closer to the right-hand side. So I'm going to try and do that from the left-hand side. Cos 2x is a double angle, sine 2x is also a double angle, so we're going to substitute that with the identity. So this becomes 1 minus 2 sine squared x minus sine x. And we are dividing this by sine 2x is 2 sine x cos x. The reason I picked 1 minus 2 sine squared x as the identity to go with that cos double identity is because we are trying to aim for a sine over cos situation, because the right hand side is actually tan. So whatever you decide to pick, it should work towards your goal of trying to prove that it's equal to tan x. We simplify this. This is equal to 1 minus 1 plus 2 sine squared x minus sine x over 2 sine x cos x minus cos x. Simplify. This is equal to 2 sine squared x minus sine x. We factorize the numerator. Common factor there is sine x. Then we have 2 sine x minus 1 left in the brackets. This is all over. Common factor there is cos x. And in the brackets we have sine x minus 1 left. We cancel out what is common in the numerator and in the denominator. You can see that the bracket there is common. So we cancel 2 sine x minus 1 and 2 sine x minus 1. What we have left is actually sine over cos. And sine over cos is an identity for tan x. So therefore, the left-hand side is actually equal to the right-hand side. We have just proven that. Part B. The above expression is undefined if sine 2x minus cos x is equal to 0. In other words, if the denominator is equal to 0. Solve this equation in the interval from 0 degrees to 360 degrees. We have already determined how to expand this denominator by making use of identities. We said sine 2x is the same as 2 sine x cos x minus cos x, and this is equal to 0. Common factor is cos x. And in our brackets, we have 2 sine x minus 1. And this is equal to 0. According to the zero product rule, either cos x is equal to 0 or the bracket 2 sine x minus 1 is equal to 0. So we solve this. And from arc cos of x, it means x is equal to 90 degrees. And this is happening at every 360 degree interval k, where k can be any value of an integer 1, 2, 3, and so forth. And we also know that the general solution for cos is 360 minus alpha. In this case, alpha is 90 degrees plus 360k. So this is equal to 270 plus 360k. Or 2 sine x minus 1 is equal to 0. So it means that 2 sine x is equal to 1. Sine x is equal to half. From our special angles, it means that x is equal to arcsine of half. So x is actually equal to 30 degrees. Again, cycling at every 360 degrees. And from the general solution, it can also be equal to 180 minus alpha. In this case, alpha is 30 plus 360k, which means it can also be equal to 150 degrees plus 360k. So this expression is undefined when x is equal to 30, 90, 270, and 150. We're stopping at this interval because it says from 0 to 360. If that restriction was not there, and then we'll still add that 360k.